So section 5, page 2, we are on the third example. Permanganate plus peroxide yields manganese ions plus oxygen gas. Step 1 says find the oxidation numbers. Do we have them? Good. Okay. So oxygen here, oxygen is usually -2. 4 of them makes all of this -8. And in order to make the compound -1, we have manganese at +7. This one's different, hydrogen peroxide. You might need to flip back to the very first page of lesson 1.4, where it says oxygen is pretty much always -2 unless it's a peroxide, which is one of these. And so peroxide in this situation, the oxygen is -1, the hydrogen is +1. The manganese ion oxidation state is same as the charge, and O2 gas is the elemental form, so the oxidation state is 0. Second part of step 1 is identify which element is oxidized and which element is reduced. So oxidized and reduced. Remember our mnemonic oil rig, or Leo goes grr. The one oxidized lost electrons, which means its oxidation number becomes more positive. So we have something becoming more positive. There'll be oxygens which are negative, becoming more positive, which is 0. That means they lost electrons. So our oxygen was oxidized and reduced, something that gained electrons. This would be Rig or Gur. Gain electrons means you are becoming more negative or less positive. That would be manganese going from +7 to +2. So that was step 1. Step 2, write the oxidation and reduction half reactions. So the oxidation half reaction has to do with the oxygen itself. So the things where oxygen shows up, let's see here. We have it is in permanganate, but since manganese is in there too, we'll ignore it for now. This one's a little bit different. So oxidation, let's do peroxide yielding O2 gas. And then you have to figure out what's going on with the electrons. So let's see here. We have H2O2 to here, and why this says 2 electrons. Okay. We need 2 electrons. So write it down, and then I'm going to explain why we have 2 electrons. There's 2 oxygens here. Each one of them lost an electron. So we had a -1 oxidation number, but keep in mind there's 2 of these, and then oxygen becomes neutral. So one of the oxygens lost an electron, and then the other oxygen lost an electron. This is one of the more difficult examples, but that's what happened. Okay, so let's look at the reduction half reaction And this one is where manganese comes up. So MnO4 minus yields manganese 2 plus. Reduction means gaining electrons. When we're gaining electrons, it's almost like the electrons are a reactant, because they're going to be a separate reactant and then they're going to become a part of everything, like a product. Okay, now we have to figure out exactly how many we need. Let's see here. We have manganese going from +7 to +2. What is this telling us? Pretty sure it's screwed up. There was a typo on one of the previous ones. Did you catch that when I mentioned it? NO2. I think there's a typo on this one too.
Because they want to multiply out to me. Or whatever.
Yeah. So I'm going to go with what the guy's paper says on this one, which is questionable, and we can figure it out and debate it later. He's saying +7 on the electrons here. Yeah. So this is the very basic version of the half reactions. Then you actually have to balance the half reactions. This is step 3. We are in an aqueous reaction. So it says balance the elements that are not hydrogen or oxygen. So in that one, it's nothing. And this one, it's manganese, but it's already balanced too. Then balance the oxygens. Balance the oxygens using H2O. So in the oxidation half reaction, the oxygens are fine. Let's look at the reduction. We have 4 oxygens here and no oxygen in the products. So what we do for this is we add 4 waters. Just for the 4 oxygens. And keep in mind, this says it's an aqueous reaction. This is happening in a container that's full of water. So there's so much water around it, and so we're just grabbing a few of them to make this work. Then it says balance the hydrogens with H+. So for the oxidation reaction, we have 2 hydrogens in the reactants, which means we need to put 2 hydrogens in the products. And for the reduction, we have, 8 hydrogens in the products, so we have to add 8 hydrogens to the reactants. I'll let you write this down before I go anywhere else. Okay. So like I said, the water just comes from the solution that's all around it. There's a ton of water there. The H pluses, you kind of have to wonder, where do these come from? But in a sample of pure water, there's already a bunch of H pluses, because water tends to just break apart sometimes. H2O, and if it splits, you get an H and you get an OH. So there's already a lot of H pluses floating around in the water too. And so that's where these come from. Just like with the water, we're just kind of grabbing them to make this work. they're in the water with everything else. Okay. All right, so step 4, make sure the electrons lost in oxidation is equal to the electrons gained in reduction. We're talking about this 2 and this 7, and they're definitely not equal. So the oxidation reaction, we're going to multiply everything by 7. All the subscripts, all the electrons, not subscripts, coefficients, all the coefficients and all the electrons. And for the reduction, we're going to do times 2, all the coefficients, all the electrons. Least common multiple is 14. That's how we came up with this. So it might be better for us to just, maybe rather than rewrite everything, and you can rewrite it if you want. But we multiplied everything here by 7, so 7, 7, 14, 14. This one times 2, so we have 16, 2, 14, 2, and 8. You can recopy these if you want. It's just going to take up a lot of space, and it's an intermediate step anyway. This is not the final step. Then we add these two reactions together. So I'm going to write out the whole thing before I cancel stuff out. So we have, let's see, 16H pluses, 7H2O2, 2 permanganates, plus 14 electrons, yields 7 oxygens, plus 14 electrons, plus 14 hydrogens, plus 2 manganese, plus 8 waters. Everybody's with me at this point, right? So now we just need to cross some stuff out to get rid of it. So 14 electrons and 14 electrons, those ones definitely need to cancel out. If those two don't cancel out, then we did something wrong up here. Let's see, we've got 14 hydrogens and 16 hydrogens. We get rid of those. That makes this one 2 hydrogens. Let's see, then we have hydrogen peroxide, permanganate, only in reactants, oxygen, manganese, and water, only in the products. So this is going to be the end of it. I'm going to write this one more time to clean it up. If you have space, then go ahead and do it. I'm going to put in the states this time. So like your aqueous, your liquid, your gas, that sort of stuff. And I don't want to start any really bad habits, but I will give you one hint for the AP. If it's something like this, where you can see the charge, it's assumed to be aqueous. So we don't have to write aqueous every time if there's a charge. So for the hydrogen, we can leave it like that. The 7H2O2s, I don't see a charge. It needs to say aqueous. Plus 2 permanganates yields 7 oxygen gas, plus 2 manganese 2s plus 8 liquid waters. Okay, so that's really about the hardest one I've seen for manganate and hydrogen peroxide one. Most of them are not difficult to this degree. So anyway, I'm still trying to figure out how I would get you to put this into Prism, because there's a lot of typing here, and it wouldn't. And I could do it in essay format where it gives you this long, huge blank, but it wouldn't grade it for you. And there's a lot of things that can go wrong looking at this when we would want to type it in. For instance, like the states. If we put the states in there, I don't know. You can't do subscripts and you can't do superscripts in Prism for the answers. So maybe this would end up being a multiple choice question. I don't know. That would be kind of a lot of work, but at least it would be easier on you. I'm still working out the details of this one. So I wanted to be able to show you what's right and what's wrong in the computer, and not have to wait like 2 days on an answer. I'm working on that. Okay, so let's look at one more and then there'll be time. So the last one, chlorine gas plus hydroxide aqueous yields chlorine ions plus ClO minus aqueous. Hypochlorite. We need to start working on our ions. Hypochlorite. Okay. So first step in our list of things, might need to go back and look at it. What's the first step? When you're doing these at home or in study hall, go back and look at the list. Step 1 is figure out the oxidation states. So 0, oxygen's -2, hydrogen's +1, -1. This one's weird. So oxygen's -2 and chlorine is +1. Figure out what's oxidized, figure out what's reduced. Remember, oxidation is losing electrons. It means the oxidation number is going to become more positive. See something weird about this? It's chlorine for both of them, right? Yeah, it's kind of weird. So, Cl and Cl. But we're still going to treat them like they're two separate reactions. We're going to look at the oxidation half reaction, and we're going to look at the reduction half reaction. So for the oxidation, it's going to start off with Cl2. and it's going to become, let's see, which of these chlorines would be part of the oxidation reaction. Remember, oxidation is losing, so it's becoming more positive. This one. ClO minus. And let's see here. We'll put our electrons, our product, because they're being lost. So for our electrons, we had 2 chlorines. Each one of them lost an electron. Chlorine number 1 lost an electron. Chlorine number 2 lost an electron. There's 2 of them. For reduction, again, we're starting with Cl2. And this time, gaining electrons means becoming more negative. Cl minus. So we are gaining electrons, which means that they're going to be on the left side of the equation. So here's an electron. We need 1 for chlorine number 1, 1 for chlorine number 2. Okay. Three, balance the half reactions. This is an aqueous reaction. Balance the elements that are not hydrogen or oxygen. So that's Cl, 2, and 2. Balance the oxygens with water. So we need to add plus 2 H2Os to deal with this. And we need to add nothing to this one. All right. And so we need to add something else. We need to balance the hydrogens, right? So this one, we have 4 hydrogens. Anything else needs balanced? Looks good to me. Let's move on. You can probably wrap this up on your own, right? If you need to go to math, you can get going, but I'm going to finish this up for the video real quick.
We need the following students to the office, please. Ruth Sagio, Charlie Stiles, Aiden Story, Clarice Wolf.
Yesterday, this list was about a mile long, so I'm just going to talk loud.
Please come to the office.
Oh, it's a little shorter today. Okay, so let's add these together.
And Oakley Porciano Barger, please come to the office.
2 Cl2s plus 2 H2Os plus 2 electrons yields 2 chlorine ions, 2 hypochlorite ions, plus 2 electrons and 4 hydrogens. That cancels. That cancels. Yep. And then I'll just clean it up. Two Cl2 gas plus 2 H2O liquid yields 2 chlorides plus 2 hypochlorites plus 4 hydrogens.